Hello, welcome to our lesson on binomial probability distribution. All right, and when do we say that, or when do we apply the binomial probability distribution in solving probability question? Okay, let's say for instance, we have in an experiment, okay, we have a number of trials. Let's say my number of trials is what? Is n. And within the number of trials, in each trial, okay, you may have success or what? Or failure. Let's assume that I'm tossing a coin a number of times. If I'm tossing a coin a number of times, I know that if I toss a coin, I may have the head or what? The tail. So the success will be maybe the head, and then the failure will be what? Maybe the tail. All right. Or you are tossing a die. All right. And if in tossing the die, we know that if I toss a die, my possible outcome 1, 2, 3, 4, 5, 6. And then so my success can be that in tossing the die, 4, let's say, shows up. All right. If 4 shows up, that will be what? 1 out of what? 6. And then the rest is what? 5 out of what? 6. So this can be my success, and let's say this can be my failure, depending on the requirement of what? The requirement of the question. All right. So under binomial probability distribution, there's a binomial because we may have one side to be the success and one side to be what? To be the failure. And with this particular approach, normally questions here, maybe we use the binomial probability, okay, to solve questions that are normally tedious to solve using the normal way. Let's assume that I'm asked a question like tossing a die 5 times. Are you going to draw the table, okay, and then if you draw it for the 2 times, you have to get to your possible outcome as well, 36. So if you assume that tossing a coin 5 times, you see your possible outcome remaining to be 6 exponent what? 6 exponent 5. And you know what you are going to do. So it will become tedious when you use the normal way, let's say drawing the table what to do. That is why we need a binomial probability approach, so that can help us to solve. Or let's say tossing a coin 10 times. You know that if I toss a coin 10 times, then the number of possible outcomes will be 2 exponent what? 10. You see? Are you now going to draw the table? So we apply the binomial probability distribution for questions that are normally tedious to solve using the normal way. All right. So let's come and then know how we apply the binomial probability distribution. So I said that, let's say you have a number of trials n, and in a number of trials, in each trial you may have what? Probability of success or failure. So let's say my probability of success is P. Okay, probability of success. And then my Q is my probability of what? Failure. All right. So let's say the probability of success is 3 over 4. Then my probability of failure will be what? 1 minus 3 over 4. Which will give me 1 over what? 1 over 4. Is that okay? All right. So if you have the probability of success, what you do is what? To subtract 1, okay? So that you can get the other way around. That's the probability of what? The failure. Is that okay? And then you also apply combination also here. Okay? So we say that the binomial probability distribution function, okay? So let's say for a variable x, can be written as what? Can be written a probability of x equal to the x, and the x here, okay, tells us the number of outcomes of whatever you are supposed to what? You are supposed to solve. All right. So let's say, for instance, if I'm solving a question on a die, okay, and then the question is asking me that I should find the probability that the die will show exactly 2 hairs. If it's exactly 2 hairs, then it should be that what is the probability that in all the outcomes I will see exactly 2 hairs. That is what? That is the x here. Okay, showing the number of outcomes out of what? All the possible what? Out of all the possible outcomes. All right. So the x here is telling us what? The number of outcomes out of all the possible what? Out of all the possible outcomes. So let's assume that I'm tossing a coin. Okay, a coin 5 times, and I'm asked what is the probability that the coin will show what? Exactly 2 tails. If it's exactly 2 tails, then I'll look at all my possible outcomes. The number of outcomes that shows what? Exactly 2 tails, and that is the x here. All right. In that case, my x becomes 2. Is that okay? All right. Then that will be equal to the number of trials combination, the x, the number of outcome the question is demanding from me. Then I'll come to the probability of success. So whatever the question is requiring from you, you take its probability, all right, then to the exponent of what? To the exponent of the x. And then you come and take the probability of what? Let's the other side, the failure. Then you make sure that you subtract the x from the n. So that will be n minus x. So this becomes what? This becomes our formula, for binomial probability distribution. All right, probability of, let's say our variable is x is equal to the x that is telling us the number of outcomes depending on whatever the question is requiring from us. Then you take the number of trials combination, the number of outcome, then probability of the success exponent, the x. That means that the x here, all right, will raise to the power whatever the question is talking about for your success. And then you take the other side to the failure, and then n minus, you subtract the x from what? From the n, and then you get your answer. So let's go and then solve an example right now. So I know from the example you understand it better. All right. Okay, so let's look at the example. A fair coin is tossed 6 times. Find the probability of getting A exactly 2 heads, B exactly 4 tails, C at least 2 heads, D at most 3 tails. All right, so we are talking about a coin. A fair coin is tossed how many times? 6 times. So we know that our n is going to be 6. All right, okay. But before we solve, take note, when you are tossing a fair coin 6 times, there's a lot of outcomes. If you are supposed to solve this question in a normal way, if you are tossing a coin 6 times, then your possible outcome will be 2 exponent 6, which will be 64. So that will be your number of possible outcomes, 64. All right. So the question, but we are not going to solve the normal, we are going to use the binomial probability, okay? But you should take note how weightier the question is. Okay. So the question is asking us exactly 2 heads at exactly 4 tails. So if the coin is tossed this, and this can be some of your possible outcomes. Maybe head, tail, tail. You see, 1, 2, 3, 4, 5, 6. Some can even be like this. I want you to know 1, 2, 3, 4 what we are dealing with. Okay, these are some of your possible outcomes. So exactly 2 hairs, then it can be something like this, where you will see only 2 hairs. Okay, in tossing of the coin 6 times. So this can be an example. Okay, so I can even so example can also be like this, where you see only 2 hairs, but there are 6. All right. So if you like, you can write your formula down, but without the formula you can also solve. So if I'm writing my formula down, and that will be probability of x equal to the x, that's the number of outcomes I'm looking at, equal to n combination x, probability of success raised to the power s, and then failure n minus x. Okay. So you are going to use this approach. All right. So as I said, my n will give me what? Will give me 6. Is that okay? Okay. So because here, we are talking about a fair coin. So it means that One will be the head, one will be the tail. Okay, so my P, that probability of success will be, so if I have the head, okay, that will be 1/2, probability of head. And then my Q, that is the probability of, let's say, the tail. That will also be 1/2. Is that okay? Okay, because if I toss a coin, I'll have the head or the tail. Okay, so probability of P, probability of head will be 1/2, probability of the tail will also be 1/2. All right. Then, let me come to number 1. Exactly 2 heads. If it's exactly 2, so probability of exactly 2 heads. Okay, that means that S is going to go to 2. Exactly 2 heads. Okay, so if it is exactly 2 heads, then that will be n combination what? 6. That my n is 6 combination 2. Then I'll have what? My P, which is the head. So 1/2 exponent 2. Then the tail, if head is showing 2 times, then since I'm tossing it 6 times, the rest will be what? The rest will be the tail. So the tail will show how many times? The tail will show 4 times. All right. So this is what I can get. Okay. So 6 combination 2 multiply by so 6 combination 2 is giving us 15. All right, so we are going to have 15, and then 1/2 square will give us what? 1 square is 1, 2 square is what? 4. So 1 exponent 4 is 1, 2 exponent 4 is what? 16. So we are going to have this. We have 15 by 1/4 times 1/16. That will give us 15 out of what? 64. And that will be equal to, in decimal, 0.2344. Okay. So this is the probability that when I toss a coin, I'll get what? Exactly 2 heads. Exactly 2 heads. Alright. Let's look at the B. Exactly 4 tails. So in tossing of the coin, I'm going to get what? Exactly 4 tails. Alright. So probability of exactly 4 tails. The tails there will be 4. So it means that my X is going to go to 4. Alright. If that is the case, I have a 6 combination 4. And what is the tail? The tail is also 1/2. So 1/2 exponent 4. Because the tail will show 4, exactly 4 tails. And then if the tail is showing 4, then the rest will be what? The head. And the head will show what? 2. So this is what I'm going to have. Alright, so 6 combination 4 also give us 15. 1 exponent 4 is what? 1. 2 exponent 4 will give us 16 times 1 exponent 2 is 1. 2 exponent 2 is what? Is 4. So it is giving us exactly like this, 15 times 1 is over 16 times. So that will give you 15 out of 64. 15 out of 60. This one, that will be 0.2344. So if you are going to have exactly 4 tails, then this is what we are going to have. And the reason being that, you see, the reason why this is the same as this is because if I have exactly 2 heads, then it means that it is the same as exactly 4 tails. Because if I'm tossing 6 times, and if I have exactly 2 heads, then the rest will be what? 4 tails. That is why we see that we are having the same probability. Alright, let's go to C. At least 2 heads. Probability of at least 2 heads. At least 2 heads. At least 2 heads. Alright, so then what to be my X? At least 2 means that the least should be 2. So 2 or more. So greater than or equal to 2. Alright. So if it at least can be 2, 3, 4, 5, and 6. because we are tossing out 6 times. So if I have at least 2 heads, then head can appear 2 times. Head can also appear 3 times, or head can appear 4, head can appear 5, or head can appear 6. You see, this is the at least 2 heads. All right. So you see that the coin was tossed 6 times. If you are supposed to find 1, 2, 3, 4, 5, it will be so long for us. Okay, so what we can do is that we can find the other way around. Okay, that head, there was no head, and then head also appear once. Okay, so in all the possible outcomes, this is what we can get. We can have that in the possible outcome there is no head. Okay, or there is only 1 head, or 2 heads, 3 heads, 4 heads, 5 heads, and 6 heads. So this is what the question is asking us. So what we can do is to find the probability that there is no head in the outcome, there is 1 head in the outcome, then we subtract from 1, and that will give us this particular answer here. Because if the probability of no head, 1 head, 2 heads, 3, 4, 5, and 6, if you put all of them together, you get 1. So if I'm supposed to find this, and then I can find these 2, and I'll subtract from 1, so that I'll get this. I believe that is clear. All right, so simple to understand. So this is what I'm going to do. It is the same as 1 minus probability of x is less than 2. So instead of greater than or equal to 2, that is 1 minus probability of s being less than 2. So that I'll find probability of s, that will be 0, and then 1. Then I'll subtract from 1 to get my answer. I believe this is clear. So this can be 1 minus, if there is no head, let's start from no head, that will be 6 combination 0, then 1 over 2 exponent 0, then 1 over 2, there will be 6 tails if there is no head. Alright. Then, or 1 head, 6 combination 1 over 2 exponent 1 over 2 exponent what? Exponent 5. So this is what we are going to have. Okay. Then you have 1 minus. So let's use the calculator. 6 combination 0 times 1 over 2 exponent 0 times 1 over 2 exponent 6. That will give us 1 over 64 plus 6 combination 1 times 1 over 2 exponent 1 times 1 over 2 exponent 5. And that will give us 3 on 32. So we are going to have 1 minus 1 over 64 plus 3 on what? 32. And that will give us 1 minus 7 on 64. And what is 1 minus 7 on 64? That will give us 57 on 64. So in this one, 0.8906. So the probability that there will be exactly, and the probability that there will be at least 2 heads is 57 on 64. 57 on 64. All right, let's go to the next question. Okay, so let's look at the last one, D. At most 3 tails. So probability of at most 3 tails. At most 3 tails. Okay, so when you say at most 3 tails, it means that the highest, okay, when you look at our possible outcomes, the highest should be what? 3 tails. So at most 3 means that 3 or less. So it can be 3 tails, 2, 1 tail, or none. So at most 3. So that is 3 tails or less. So it can be 3, can be 2, can be 1, can be 0. So 1, 2, 3, 4. Let's look at the other way and look at where when we solve it, it will be simple for us. Okay. So that in the other way, if we have 3, 2, 1, we are tossing the coin 6 times. So we can have what? It can be 4, can be 5, and can be 6. Alright. 4, 5, and 6. So what we can do here, the at most 3 tails is 3, 2, 1, 0. That is 3 or less. So that one you have to do what? You have to do it probability that there will be 3 tails, 2 tails, 1 tail, or 0 tail. So when we look at the other way, it can also be probability that 4 tails, 5 tails, and subtract from 1. So this we have 1, 2, 3. Okay, we have 3 possibilities. So we can do the 3 possibilities and then we subtract from 1 to get this. Alright, or we can also do this. Any way you want to do it, depends on you. But the one that will be easier for us. Okay. So at most 3 tails, it means that probability of my x is at most, that is less than or equal to what? 3. If it is less than or equal to 3, then we can have what? We can have 0, 1, 2, and then 3. That is at most 3. Okay, less than or equal to 3. So let's do it this way. Then we also try the other one and see. Or I'll give to you an assignment and also try. So that will be what? We will have 6 combination 0. We are talking about tails. So tails is 1 over 2. So 1 over 2 exponent 0, 1 over 2 exponent 6. So if the tails is 0, then the head will be 6. Or 6 combination 1, 1 over 2 exponent 1, 1 over 2 exponent 5. That is when the tail is 1. Or 6 combination 2, 1 over 2 exponent 2, 1 over 2 exponent 4. That is when it is 2. Or 6 combination 3, okay, 1 over 2 exponent 3, 1 over 2 exponent 3. So here the tail is 1, 0, 1, 2, and then 3. So let's put it on the calculator and then we see. So 6 combination 0 times 0.5, which is 1 over 2 exponent 0, times 1 over 2 exponent what? Exponent 6. That will give us 1 over 64. 1 over 64 plus, then we come to when it is 1. That to be 6 combination 1, 1 over 2 exponent 1, and then 1 over 2 exponent what? Exponent 5. That will give us 3 on 32 plus, then we come to 6 exponent 2 times 1 over 2 exponent 2 times 1 over 2 exponent 4. And that will give us 15 out of 64 plus 6 combination 3, 1 over 2 exponent 3, and then 1 over 2 exponent 3. That will give us 5 over 16. So at most 3 tails, that is 3 tails or less. So 0 tail is 1 over 64, 1 tail is 3 over 32, 2 is 15 over 64, and then 3 tails is 5 on 16. So let's add up. 1 over 64 plus 3 on what? 32 plus 15 on 64 plus 5 on 16. So 1 over 64 plus 3 on 32 plus 15 on 64 plus 5 on 16 will give us 21 on 32. In terms of decimal, that will be 0.65625. Okay, that is in terms of decimal. So the probability that we will have at most 3 tails is 21 on 32. Okay, 21 on 32. I believe you get this. All right, so we will meet again in our next lesson. Bye bye.